This is section 2, algebraic approach to limits, example 3. So in this example, we're going to look at where the limit, if you just plug in -2, ends up not existing. Because if you just look at this equation, right, for part A, starting with part A, -2 squared is 4. 4 minus 4, 0. Can you divide by 0? No. And that's the whole thing that we were talking about at the beginning of the last section, right? It ended up being a hole right there. And that's fine, but that means that just plugging in the number is not going to give us the answer. So let's go through the algebraic way to do this instead of trying to make a table. Really what we're going to do is manipulate it algebraically, this equation. And you know a lot about rational functions, or at least you should. And what you should remember first is that they're factorable, possibly, right? This is factorable. Factors of 6 that add to 5 are 2 and 3. So, oops, I almost forgot. We're finding the limit as x approaches -2. So we get x plus 2, x plus 3, because 2 times 3 is 6, and 2 plus 3 is 5. X squared minus 4 is the difference of squares, so we get x plus 2, x minus 2. And we can cancel x plus 2's, which is very good because we're plugging in -2, and remember that's where -2 cannot exist, which means there is a hole there. But again, we're not worried about what's happening at -2, we're worried about what's happening around -2. So it doesn't matter that it's not defined there. What matters is that the limit exists. So let's see what happens. We're still finding the limit, right? Haven't plugged anything in yet. As x approaches -2, I'm just going to rewrite the equation so we get x plus 3 over x minus 2. And when I plug in -2, we get -2 plus 3 over -2 minus 2. Okay, because I plugged it in there, I no longer have to write the word or the symbols lim as x approaches -2. Okay, and then -2 plus 3 is 1. -2 minus 2 is -4. That's the answer. That means that there's a hole there, but the point is -2, 1 over -4. Or -1/4. Okay, that would be the point where the hole would be. Let's do another one. Well, that one looks potentially complicated for 2 reasons. In B, we're finding the limit as x approaches 0 from the right. Now, this is only an issue if there's an asymptote there. And we're going to hope that maybe there's not. All right. Otherwise, even though you're finding the limit from the right, it possibly will be the same as the limit from the left, which would be just the overall limit. So keep that in mind. Now, notice these exponents are fractions. And I know everybody loves fractions, right? But we're still going to just try to factor it and see what comes out and what we can end up dealing with. Maybe it'll make it a little bit easier to deal with. Hopefully, it does. So when you look at these exponents, if you look at the numerator, we've got 3 halves and 7 halves. Well, 7 halves is bigger than 3 halves, so I can take out 3 halves. So that's what I'm going to do. We're going to find the limit as x approaches 0 from the right. And, oops, sorry. And I'm trying to factor out x to the 3 halves. So what's left on the inside, if I take x to the 3 halves out of 9x to the 3 halves, I just have 9. And if I take it out of x to the 7 halves, remember when we're dividing, all you're doing is taking the exponents and subtracting them. So 7 minus 3 is 4. 4 over 2 is 2. Okay, and I'm going to try to do it to the bottom too. If you notice, we have 5 halves and 3 halves. And again, 5 halves is bigger than 3 halves, so we should be able to take it out. Okay, and again, we're going to subtract. So 5 minus 3 is 2. 2 over 2 is 1. So we just end up with x minus 3. Which means that these two things cancel, which is wonderful. It's going to help us out a lot. So we're really finding the limit as x approaches 0 from the right of 9 minus x squared over x minus 3. Okay, now, your first instinct might be, oh, hey, look, there's 9 minus x squared. That's a difference of squares. Shouldn't I just cancel them? And you could. Or you can just try to plug in 0 and see what you get, right? Maybe it'll be a little bit less work. Well, if I plug in 0, I don't get anything that's undefined. So I don't actually need to cancel anything. Whatever I get is going to be the answer. And I would get there whether I canceled or not. Okay, so 9 minus 0 is 9. 0 minus 3 is negative 3, and 9 divided by negative 3 is negative 3. So that's it.